Hey grade 11s, welcome to Tuesday morning, May the 5th, and I just want to say thank you for joining the class chat yesterday. It was good to see you once again, and I want to thank you for being there. I want to thank you for continuing to put effort into physics and to continue doing the effort. It makes me knowing that you are watching these videos and doing the assignments and keeping up on things makes it a lot easier for me to motivate myself to come in here and to teach to this empty classroom day after day. And so I want to thank you for doing that, and I want to encourage you to keep going on that. For those of you that joined us yesterday in the class chat, I talked about at the end a devotional that I'm doing on a variety of things, but on one thing is knowing that God is with you now. And so a verse for the day today comes from Isaiah 41:10, and it is on that same theme. So it says, "So do not fear, for I am with you. Do not be dismayed, for I am your God. I will strengthen you and help you. I will uphold you with my righteous right hand." Again, I am, I will, are all present statements. It's not that he will be in the future at some point, but he is with you now and will be forever. So let that encourage you as we go through today, as you go through today. All right, let's get to some physics. As we get started today, we want to look at question number 10 from the assignment yesterday. And here we'll go through it. So in question number 10, you've got a sound source that is playing a middle C, which is 262 hertz. And then the question says, how fast would the source of sound have to go to raise the pitch to 271 hertz, or a sharp C? Use 343 as the speed of sound. So the first thing I do is I recognize, what am I given? I'm given frequency of the sound, so Fs, 262 hertz. I'm given the frequency that I want to detect. So the frequency detector is 271 hertz. The velocity of sound, which is just V in our formula. Remember, don't confuse that with Vs. Vs stands for velocity source. So the speed of sound, 343 meters per second. We want to find Vs. Here's our formula, of course, that we talked about yesterday. So plugging into our formula, we're going to get 271 equals 262 times 343 over 343 minus Vs. Now, at this point, you have to rearrange this to solve for Vs, and there are a few different ways and orders in which you can do it. Here's how I did it. It may not be the easiest way, there may be other ways, but it's up to you. As long as you can solve for Vs, I don't really care what order you do things in. So what I did first was I took this denominator, 343 minus Vs, and I multiplied it on both sides. So that makes this 271 times what was the denominator equals the 262 times 343. So essentially all that has happened is this piece here has moved up there. All right. Then again, now I want to isolate this Vs by itself, so I divided both sides by 271. So this 271 ends up underneath, below, in the denominator. All right, now I calculated this, because this is just two multiplications and a division, so I calculated that. That gave me this 331.6 meters per second. And then to solve for Vs, I subtracted this 343 from both sides. All right, so that gave me the 331.6 minus the 343, leaving me with a negative Vs. Okay, so the negative Vs is negative 11.3. Divide both sides by negative 1, and you will get your final answer of Vs, V source, equals 11.3 meters per second. And again, remember directionally, because we're hearing a higher pitch, all right, that's a higher tone, higher frequency, higher pitch, this object must be moving towards, and so we got an 11.3, a positive 11.3, which tells us it's moving towards the detector. So that's how you do it. If you have another question on that or something that needs further explanation, make sure you ask. Today we want to talk about just two quick things concerning speed of sound and sound waves. So first thing we're going to look at is something called Mach number. Now you've all heard of Mach numbers. You've heard of airplanes traveling at Mach something, 2, 3, 4, whatever that is. You've heard of other things that travel at Mach numbers. And so we want to talk a little bit about that. A Mach number is simply a number that tells you how many times faster the object is moving than what the speed of sound is. So if you are traveling at Mach 2, that means you are going 2 times the speed of sound. And so, simple formula, simply Mach number equals the speed of the object, whatever it is, over the speed of sound. You get a ratio, and that becomes your Mach number. So again, it's just simply a ratio of how many times faster than the speed of light you are. Now, when you travel faster than the speed of the light, something happens. You cross what's called the sound barrier. Now, barrier is in quotes because it's not actually a barrier, but it acts like a barrier. So here I've got a dot, and this dot is traveling to the right here at a speed that is approaching the speed of sound. And what happens as it approaches the speed of sound, there's sound that is emitted off of this particle. And if it was stationary, it would just be concentric circles that are traveling out in all directions from this point, right? Now, if we take and we move this object at the speed of light, or speed of sound, not speed of light, can't travel at the speed of light, at the speed of sound, what happens is now it's going to be moving this way, and those formerly circles, concentric circles, are now going to become elongated. They're going to go like this. And the ones in front here are going to be really close together, while the ones behind it are going to get further and further apart. Okay, and so what happens is right here we have this barrier of sound waves. Okay, now as you get to the speed of sound, this gets more and more bunched up in the front here, and then when you go faster than the speed of sound, what happens is you now get in front of the sound, and what happens there is you get these circles, these overlapping circles behind it. Okay, and that's called a supersonic wave. All right, and so there's just a lot of energy in these waves, because when now we have crests and troughs forming super crests and super troughs in behind here. And so there's a lot of energy in these waves, but the source of sound, the airplane, whatever it is in front of the sound waves, right? Which means all the sound and all the energy is behind it. All right, and so now instead of having waves on both sides of the object, you've got overlapping crests and troughs in the back, which gives you lots and lots of energy. And so if an airplane were to fly low to the ground over top of buildings, etc., if it was traveling faster than the speed of sound, this supersonic wave behind it could cause damage to things, depending on how low it is and where you are in relation to the supersonic wave. It could rattle your windows, could break windows, could do a lot of damage if it was too close to the ground, traveling faster than the speed of sound. All right, so that's all I wanted to talk about today, traveling faster than the speed of sound. So we have a Mach number that tells you how many times greater it is. We have supersonic waves that happen when you go faster than the speed of sound, when you break through the sound barrier. All right, all we're going to do today is a few questions off a handout, off of a different textbook that I have for you. And you're going to do a few questions. I think there's like 6 questions that you're going to do. It's going to be on a handout. You'll find it on Connect. Do those questions. Ask any questions that you might have. And we will continue going through some more stuff on sound. As I mentioned yesterday in our video chat, we're going to move into some theory of sound in music and in musical instruments. So that's what we're going to head into in the next few days. So you can look forward to that. And yeah, have a great day. We'll see you tomorrow.